Hi, good evening everyone. Today I Shiva Prajapati and Sahil Sharma, mentored by Professor Marine and Professor Rekha, are going to present a research paper titled Attendance Portal Using Face and Speaker Recognition in International Conference on Intelligent Cyber Physical Systems and Internet of Things 2022. So starting off with introduction, we know that attendance is a process of recording a person's presence in some meeting or any human gathering. It is important for both academic and offices. In it, academics, it can be used to measure a student's academic performance, to measure uh, his attendance in classrooms, and in offices, it can be used to measure a employee's productivity and to keep account on the leaves. So there are several methods to do so right now. The existing conventional method include the basic pen paper, and the modern methods make use of radio frequency identification, fingerprint, and retina, including face and voice recognition. For face, the most popular method is Haar cascade, and for voice recognition, the famous method is using Mel frequency capsular coefficient. So our idea here is to combine both face and voice recognition using convolution neural networks, which can help in avoiding proxies. So some more depth on the existing recognition techniques that we have. So for object detection, we have cascade classifiers, which are basically cascade algorithms that are trained on positive and negative images. Cascade algorithm is numerical method for calculating function values of the basic scaling and wavelet functions of a discrete wavelet transform using an iterative algorithm. So when we train for some object, the object can be anything like any animal, car. In face recognition, it's human face. When it is trained, it is able to detect human face in a given image, and on that detected image we apply half features, which are basically convolution kernels. These kernels extract face features for recognition, which uniquely identifies a person. This was about face recognition. In voice recognition, if different features are extracted from voice frequency, pitch, energy with respect to time of a person. Every person has different speech characteristics that is exploited here. So various techniques that are used for voice recognition are linear predictive coding, gamma tone frequency capsule coefficients, Mel frequency capsule coefficients, and power normalized capsule coefficients. So MFCC is the one that is popularly used. So using all the background knowledge, our study boiled down to these three objectives. The first one being dataset building by taking images and voice samples of a number of people and its subsequent pre-processing. This is the data building step. Then dataset building step. Then we have model construction and training with parameter tuning to achieve acceptable accuracy of the convolution neural network model that we are going to define. And the third one being to build a user interface to access, use the above built model and subsequent reporting of attendance. So to fulfill the objectives, the steps in methodologies are as follows. First one is being that both voice and face will be used to create a data point. So basically, when image is inputted, so basically the image from the data set is converted to grayscale uh, after detecting the face using the cascade classifier and cropping it, and the size is made to 500 into 500 pixel. So for voice sample, spectrogram is generated, which is again converted to 500 into 500 dimension. Now these two are merged. When I say merged, basically image is a 2D NumPy array, and same with the spectrogram. They both are made the first layer and second layer of a 3D NumPy array. So that forms a data point. Then CNN model with convolutional max pool, flatter, and fully connected layers was built, that is explained in coming slides. Training on the training data set and testing on the validation dataset was done. The splitting was done so as to ensure that if we take 5 images of a single person, then 4 goes for training and 1 goes for testing. Then the last one being interface to register students, use model and record attendance. On the left side is the architecture when we use this system using the interface. Initially, the image will be captured and voice will be recorded from microphone. Then face detection and cropping and conversion to grayscaling is done and making to a fixed size. Similarly for voice sample, it is converted to spectrogram of fixed size. Then these two are combined, which is the pre-processing. So the combining is shown on the right hand side, where we can see if a face and a spectrogram being combined into 3D NumPy array. Then this data point is recognized by model and attendance is stored subsequently. This is the architecture of the convolution neural network form. The first layer is the convolution layer, which accepts input of 500 into 500, having 32 kernels, followed by a max pool layer of 32 kernels. Similarly, a pair of convolution and max pool having 64 kernels and 128 kernels. And after that, we have a flattened layer, and at the end, we have a softmax layer for the classification of identified person. So the results that we achieved are shown in this slide. This is the first graph shows accuracy versus epoch graph. So by trying out various epochs and tuning various parameters, we finally arrived at this where we trained for 25 epochs, and the graph shows accuracy in each of the epochs, where blue line represents accuracy and orange line represents the validation accuracy. Same on the right hand side, we have the loss versus epoch graph. So the combined accuracy achieved was 95.45% and validation accuracy of 82.35. Now let's start with some demo.
So now I will begin with the implementation part. Now for the building of the model, we have written our code in Python language, and for that we have made a collab file in which we have imported our data set and as well as written the layers of all the layers that are required for CNN. So in this particular code, first of all, we are importing our mounting our drive and then importing the data set which is stored in particular location. So in this, I'll first demonstrate how the audio is being used. So in this, we are importing an audio file. A test audio file is being imported over here, and this is the graph for that audio file against frequency. And then we are converting that audio file using this librosa function, which is available in Python, to a spectrogram, which is shown over here. And after that, this spectrogram is combined with the image of that particular person, and data point is created. And for that particular part, we have written code over here. So I'll go a little bit downwards. Over here, you can see that over here we are importing all the data set. We have written a for loop over here in which we are taking in all the data set from the drive and one by one combining the image as well as audio of the of a person and creating a data point. We are basically converting our image into a grayscale image and forming a layer of that, and along with that we are converting our audio into a spectrogram and combining them both together to make a one data point of 2 layers. And then this data point is fed to our CNN model, and then the model is built. So for CNN, we are writing layers over here. So CNN model is defined over here, and then we are defining all the layers that are required for that model. So the first layer that we have defined is convolution layer, which is having 32 filters initially, and the kernel size is 3 by 3. The activation function used here is ReLU, which is a rectified linear activation function, and the input size is 500 cross 500 of grid size of 2 layers. And the second layer is max pooling layer, which is also having the kernel, 2 by 2. And the third layer is convolution again. Then it is having more filters, which is 64 in this case. The kernel size is same. And then again one more max pooling layer is there. Then 2 more convolution max pooling layers are there, and after that we have used a flattening layer, and after that we are using density layers to and with the different activation functions. Both the density layers have different activation functions. So one is having relu and the other one is having softmax, and at the end of this model is being saved to a local system, to our drive, and then we by this name, and then we can use this model anywhere in our Python code. Any Python code can use this model, so that we don't have to train a model again and again. Now I'll go to the code where we have written the part for the front end, code for the front end. So this is the code that we have written for the front end, and in this one we are using tkinter library of Python, which is a very robust library to make graphical user interface in Python. And this one we have integrated our model together along with the graphical user interface to make it more intuitive. So I'll go to the demonstration part. So this is the whole UI that we have built. It has multiple buttons over here. One is a new registration button. So we want to register new user and update our model. We can enter the new data of new student over here, and then take images as well of that particular user, and then improve enter that the data of that particular user in a data set. And then we can take attendance from here. In attendance, we have basically two methods. The first method is the main method that we have used over here, which is based on CNN. It takes in an image as an input, and then later on it takes an audio as well. And then on the basis of those two things, it gives us a combined output. It gives us a prediction whether the user that is the image of the user belongs to that particular user or not. But for some reason, if this method does not work, then we'll go to method 2. In method 2, we only take image as an input, and in this case we are using Haar cascade classifiers as well as LBPH, which is local binary histograms patterns, to recognize the face and predict the face of the person, and recognize the face of the person. So this was all about the UI and model part. So now going back to the PPT, so we can conclude that at a small scale, the system works pretty well, and it performs pretty decent, but still has a great scope of improvement. With larger dataset and more deeper neural networks, we can improve the performance of the system by a larger extent. And we can also make a mobile application for it, and due to which we can be used with multiple devices. Its features can be enhanced further by integration with CCTV surveillance cameras, in which we can use it for theft detection as well as some other features also. So overall, it's a very promising method of attendance, and can have a great deal of implementations. So that's all from my side. Thank you.